We're going to talk about geometric sequences today. We've studied your arithmetic sequence. Remember, that's when you add or subtract a number to go from one number to the next. To contrast that, geometric sequences are going to be multiplied or divided by the previous number to another number. In fact, we're going to be considering that what we call a common ratio. So, for example, if we see the sequence 5, 10, 20, 40, if you take any two numbers in the list and you divide one number by the number that comes before it, you're going to find the common ratio. So, for example, if we do 5 divided by 10, 20 divided by 10, or 40 divided by 20, 10 divided by 5, 20 divided by 10, 20 divided by 20, 40 divided by 20, you're going to get an exact 2 as that ratio. So whenever this happens, you have what's called a geometric sequence. If you divide each term by the term that comes before it and you get a different number at any point, then there's something off about that ratio or the sequence, and that's not considered to be a geometric sequence. If we look at another one, this is kind of where it goes smaller. You have a 10, a 5, 5 halves, 5 fourths, 5 eighths. You can take any two numbers in the list, just like before. If we take the 5 divided by the 10, we're going to get 1 half. If we take 5 halves divided by 5, we're going to have to go to fractions here. So 5 over 2 divided by 5 over 1. Remember to multiply by the reciprocal. So the 5s cancel out, and you're left with the 1 on the top and a 2 on the bottom. Again, you get 1 half. If I were to do the same thing again with the two fractions, let's say if we did 5 eighths divided by 5 fourths. We're going to take that denominator, we're going to flip that over to be 4 fifths. You're going to cancel that out, and that leaves you with 4 over 8, which reduces to 1 half again. So it doesn't really matter where in the list you do this division, you're going to get that common ratio. So when the question asks you, is this sequence a geometric sequence, the process you're going to take is you're going to do any term divided by the term that comes before it. Don't do it just once. You want to do it for all the numbers they listed just to make sure that that ratio is consistent. Now, in example 1, I wouldn't do it every time because I can see that I'm just multiplying by 2 every time. But if you get something like a fraction, like example 2, you might want to think about it. I think I can probably tell that that one's just multiplying by 1 half every time. But if it's not clear, do the ratios to make sure that each time it's the same. All right. Our explicit formula for this section looks like this. We have an equals a1 times r to the n minus 1 power. And again, a lot of these things are the same as before. My first term is still denoted by a1 out front. The r is the common ratio that we have. And then, of course, my n just tells me which term I'm on. If I'm on the third term, then it would be 3. N would be 3 in both cases, 3 here and then 3 there. Let's do an example to kind of show you how we would do a few things with this formula. Number 1, example 3, we're going to find the common ratio, then we're going to find the 10th term and the explicit formula. We're actually going to do the explicit formula next and then the 10th term at the end. So what we're going to do here, if we take any two numbers, this will be really easy. 6 divided by 3 is 2. 12 divided by 6 is 2. And you can clearly see that I'm just multiplying by 2 every time. So clearly, our common ratio here is 2. Now, let's find the explicit formula. This is pretty easy once you have r in the first term. We know that my nth term, so my an, is equal to the first term, that's going to be 3, times the ratio to the n minus 1. And that's it. In order to find the 10th term, we're going to say, I want to find a10. What we're going to do is we're just going to plug 3 times 2 to the 10 minus 1. Now, this particular unit, you're going to really want to depend on that calculator because you're going to get some really big numbers and some really small numbers. So doing the calculator thing is going to be pretty much a necessity here because I do not remember what 2 to the 9th power is. off the top of my head. And so that would be 1,536. So again, this is what we call our nth term formula, or our explicit formula. And you'll see that written into the questions. It will say, find the explicit formula for the sequence. Let's do another example. Here you can see that I'm starting off with a really small number, and that number increases each time. And I can start off at the top. If we wanted to find our common ratio, if you take 100,000 divided by 1,000, that's equal to 100. If you take 1,000 divided by 10, that equals 100. And you can clearly see if I continue to do that, even if we do 10 divided by 1/10, right? Remember, you multiply by the reciprocal, 10 over 1, and we're going to treat that like 10 over 1. So 10 times 10, again, is 100. And if I continue the process, I'll see the same thing is going to happen again. So let's find my formula. AN is equal to the first term, so 1 over 1,000, times my common ratio, R to the n minus 1. And you can check this out. You can try this by plugging in 1, do I get 1,000, 1 over 1,000. If I plug in 2, do I get 1 over 10? If I plug in 3, do I get 10, and so forth. It's easy for you to just try to plug in 1, 2, 3, and get the numbers in your original list. You can definitely do that and make sure that you're getting it in the right way. So let's find our 10th term. So we're going to do a 10 is equal 1 over 1,000 times 100 to the 10 minus 1. So this seems like it's going to be a pretty big number. So I'm being very careful in my calculator with parentheses and things like that, and as well as with fractions. I encourage you to use the fractional buttons that you have access to in your calculator, just so you don't accidentally type it in wrong. I'm definitely using parentheses in mine. And that little caret button, by the way, we call it caret, but it looks like this. If you're not used to that, this button right here, it's just underneath the clear button on the TI-84 calculators, the calculators I have in my room. You may have like X to the box like that. That's your exponent button. So make sure that you utilize that button. Learn how to use that. If you haven't used it before in your calculator, now is a really good time to figure out how to do that. Now, because this is a pretty big number, my calculator is returning something that looks like this, 1e15. Now, what that means is that's 1 times 10 to the 15th power, or 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 zeros. So that is a big number. What is that? Millions, billions, trillions. That's 1 quadrillion. Big number. Okay. Answering your problem like that is perfectly fine. Although I don't think you're going to have numbers in particularly that big. That's totally fine. All right, next. Here we have a very similar type question that we used in the arithmetic sequences. I'm going to give you 2 separate numbers, and we need to figure out what the explicit formula is from 2 kind of random numbers in the list. We're going to be using our explicit formula to kind of work this out. So obviously I have the first value, so I've got A1, that's nice, and I've got the 6th term in the list, which is negative 2,048. What I need to figure out is R. So in order to write this equation, we need A1 and we need R. So the first thing we're going to do is we're going to plug in our A1, and then we're going to use our negative 2048 to be the AN, and we're going to let N be 6. So to start with, we're going to just apply that rule and plug in everything we're going to do. Now, obviously, we have some sort of an exponential kind of situation happening. So we're going to, first of all, we're going to divide both sides by 2, and then we're going to simplify the 6 minus 1. So that's going to give us something like this, right? So we'll end up getting negative 2048 over negative 2. That's going to end up giving me 1024 equals r to the 5th power. Now, in order for you to solve that kind of problem, right, so you have 1024 equals r to the 5th, we need to take the 5th root of r to get that 5 gone. That's the idea where it comes from. So we got to, instead of square rooting something, you're going to take whatever the exponent is, you're going to take that root of it. And just so you know, if you have one of the TI-84 calculators, then in order to get this button, and on, if you have a scientific calculator, you can probably see this on your calculator, but in order to get it on one of my calculators, it's if you press math on the left side of the, it's the third button down on the left side, and go down to number 5, you'll find this button, and it'll give you some options, and you want to type in 5 for the little root here, and then you want to take the 5th root of 1024, which is equal to 4. Side note here, a root is the same as a fractional exponent, so you could also do 1024 raised to the 1/5, and make sure that's all in an exponent, and it would be the same thing, because 5 times 1/5 is just 1, so you get 5, or r to the 1st power. So this is a kind of a faster way to do it. If you want to use kind of those exponents, you are welcome to. Like a 3rd root would be 1/3, but you're also able to do it this way as well. And so then you would end up getting your r to be 4, and now I have to go back in, and at the final step, we have to write that rule. And so we'll plug in our original a1, which is -2, and our r, which is 4, to the n minus 1, and that's it. The last example is, not example, the last topic is about convergent and divergent sequences. And so the way that we tell if something converges to a specific number, in other words, if the number eventually becomes a single number, or if it's just going to continue to get a different number and gets bigger and bigger and bigger and bigger forever, either positively or negatively, then we can see what happens. What we mean by converges, it means that if you, for example, take the sequence in B, 1/2, 1/8, 1/16, this value doesn't continue to change forever. It's getting smaller and smaller and smaller and smaller, and eventually it will be so small, it will be equivalent to basically 0. So we say it converges to one number eventually, and even though it continues on forever, the number that you are looking at is basically the same number every time. Example A, you can tell here that this sequence is getting larger, and that number will never ever end. It will continue to get very large forever, and it doesn't converge to any single value. So we say it diverges. We'll talk more about divergent and convergent series when we get to the series portion of that next week, or at least at the end of next week. So the short way you handle a question like this is you want to find your R value. So if we do 256 divided by 64, that tells us that's 4. If we do 64 divided by 16, that's 4, right? So my R here is 4. And because this value is larger than 1, we would say this diverges. Here, you can see that your R is equal to 1/2. You're multiplying by 1/2 each time. Because the R value is less than 1, we would say this sequence converges. And that's all you have to do here. Find the R value, and if it's larger than 1, it diverges. If it's less than 1, it converges.